Well, hello, boys and girls. Welcome to 10J, Quadrilaterals in the coordinate plane. There's a warm-up slide, which I'm going to walk you through some of, and then I'm going to leave some of blank, and you're going to do on your own because, hey, I already know how to do this stuff, and you might not. So you're going to plot the points -2, 2, so that's -2, Q, that's right, cheer. 0, 2, right there. 0, 0, also known as the origin, and -2, 0. So there's the shape. What shape was formed? Well, hopefully you're able to get a square out of that. And what is the length of each side? You could practice the distance formula here. That's the part I'm not going to do. Or some of you might remember that when we have a slope of 0 or a slope of undefined, all you have to do is count the units. So each side is dos, which is Spanish for 3 minus 1. Next page. Some things we need you to recall. I need you to recall that coordinates are of the form xy. Hopefully you didn't sleep through all of Algebra 1, and so you know that. Points positioned on the x-axis are of the form x, and then what? What would go here? So if a point is on the x-axis, the y value is 0. Points on the y-axis have an x value of 0, and then I need you to label the quadrants. So that's 1, 2, 3, and 4. Okay? And these are called Roman numerals, made famous by ancient Greeks. Next page. The missing coordinates. So what we're going to do is we're going to observe the figure just by looking at it. So consider that done. What's the length of AB? So how far is it from this point right here to this point right here? And the way to know the distance is just by looking at the x value. We went from 0 to a. So the length is a, lowercase a. What's the distance from B to C? Well, from B up to C, we went from 0 again to a. So the distance there is just the lowercase letter a. No problem. So finding missing coordinates, we're going to use properties that we know, and then we're going to apply those properties to shapes with, on the coordinate plane. Okay. So here we have, this is 0, 0, obviously. This is a 0. So if we take a look here, what shape is this? Rhombus. Very good. So this distance here is a. This distance, we have to be comfortable with a couple things. You got to be able to label things that were given. Okay, and here's what I mean by that. We want to be able to show that this distance right here, from here to here, that's B. Okay, the height, okay, up, we went from 0 here to C. So this height right here is the letter C. So we're asking for this coordinate over here. Well, the y value, it's up C. So I know already, that's the world's worst parentheses, that the y value is C. The x value, if from here to here is A, then that's the same as from here to here because they're congruent because it's a rhombus. We started at B as the x value, so we're going from B all the way to out here, the distance of A. So this is very simply B plus A. When we find these coordinates, we're not, it's important that you understand, we aren't looking for numbers here. We're looking for actual coordinates that have variables instead of numbers. I know for some of you that's going to seem complicated, but I think the more of these you practice, you see that, as long as you can apply what you know about parallelograms, that you can find the missing parts pretty easily. So here's some trivia for you guys. I decided to insert some trivia into the video. The PlayStation 4 is actually called PlayStation 4 because it is the 4th PlayStation. So a little trivia there you may not know. You're welcome. Alright, so now you try. So let's take a look at this one. I say you try. We're going to do it together. Don't freak out. Name the missing coordinates for the parallelogram. So it's a parallelogram. We went from 0, 0 to B, 0. So I know this distance right here from here to here is B, which means this distance right here is also B. I take a look at this, and this is B plus C. So this is B from there to there, plus this new variable C, which means that D, to start with, this distance right here, it must have gone over just the C. That's how we got the x-coordinate of B plus C. All right, and then if you look up, the C coordinate, it's up A. The Y value is A. Well, it's got to be the same for this point D over here. So this new point is C A. And that's it. Let's take a look at another one. So if you're looking for a point, I like this kind of problem. In the figure above, what must coordinates of D to show, don't mind that, we had a small earthquake while filming the video. Right now we're looking for a point. So what, in the drawing above, what must the coordinates of D be to show ABCD as a square? So you might be able to do just sort of common sense guessing here to get this. You know, just try eliminating answers. If you look at point F, F is 7, 7, so that's going to be over there and then up here. Well, that's obviously not a square, so that's not right. Look at G, 4 and then up 5. That's going to be something like that. That one might be right. I don't think it is. I don't think it's up high enough. If you look at H, that is 4, 4. That would be right there, so that's no good. You look at J, that's over 4 and up 7. Okay? And success. That is the correct answer. Okay? Now we could use distance formula. If there were 2 points that were close and we weren't sure, we could certainly use distance formula to make sure that the diagonals are congruent and perpendicular. But for this problem, it was easy enough just to tell by looking at the points that we were given. So now we're going to try one. So 3 vertices of a parallelogram have coordinates 1, -4, 3, 8, and 5, 0. Okay, so these are the points that we're given. What are the coordinates of the second quadrant vertex? Okay, that's a huge hint right there. Second quadrant vertex instantly lets me know that a couple of these answers are not correct. Okay, I instantly know, this is the second quadrant right here. Well, 1, -4 isn't in that quadrant, so it can't be A, and it can't be C. That's in quadrant 1. So I'm already down to just B and D. So I'm going to graph the 2 points. I'm going to go to -1 and 4, and I get that. Okay, and then -3, 12, and I'm all the way up here. Okay, which one of those makes a parallelogram? Well, if you just want to look at like slope, these two right here are both parallel because they have the same slope. This is up 4 and over 4 with a slope of 1, same as this right here. And then if you look at these other two sides, this is over 2 and then down 8, or down 8 over 2, so that's -1/4, and so is this. So those are, that's the correct answer right there, -1, 4. That's it for this unit, guys. Make sure you come in ready for the quiz next time on let's see, I'll show you exactly what it's on. It's on rectangles, rhombi, squares, trapezoids, and kites. Make sure you come in ready for that, and then we'll do some practice with coordinate plane geometry. All right, see you next time. Bye.